All right, let's now go back to the slides. And so these are the two classes we just went over, and we're going to see how we can build a chain of nodes like this. Let's assume that every element is a string, of course, and then it's going to be maybe storing names of person. Let's say we want to set up Alan, Mark, and also Tom. That will be the chain of nodes we will eventually would like to build. You can definitely pause the video and see how you may actually build such a chain of nodes. There will be two approaches I would like to show to you. You can see which one you feel more comfortable, but at least you should understand both of them. All right, approach number 1 and approach number 2, right? Let's now go over one by one, all right? Let's now just switch to iPad and see how they work individually, right? All right, approach number 1. So this will be, by the way, so I only include the node class over here. At this point, the singly linked list class is not relevant. We are only building a chain of nodes. We are not really trying to set maybe the head reference of the list to some node. We are not doing that yet. We will do that maybe in the next part of the lecture. All right. So now we are only focusing on the definition of the node class, which is here. All right. And let me just remind you very quickly, we got these two attributes over here. So that will be very important for us to visualize how the objects are being created. Number 1. Number 2, the methods that we're going to use mainly will be the constructor over here, which will just initialize the elements and also the next reference. And also we have to, actually in this particular code, that's all we need. And that's it, right? Let's not try to introduce the unnecessary information. So these are the only things we need. You can disregard other things just for now. Right, let's now try to do line by line. Okay, the first one, how do we visualize the effects of this, right? What's gonna happen is we're gonna have a new object over here of type node, right? And as we said before, this is how you visualize the node objects at the runtime. So what you can do is you can simply say it's a node object over here. Every node has 2 attributes. So one is elements, and the other one is the next reference, right? Hey, let me just copy this template over here because we're going to build another 2 node objects. So I can just copy and paste. All right. All right. So how do we set it up? You can see, first of all, the Tom is set to be the elements, right? You can see the Tom will be E. E is assigned to the elements, right? Of course, you can also say this dot element if you wish, right? That's but just unnecessary at this point. Right, so that means element is going to be set to Tom, and the null reference over here is very important. That means intentionally we may just want to make Tom the last node of the chain, right? So that means next is going to be set to null in this case, right? You can see the parameter over here, right? So if you really struggle with the basic tracing like this, you definitely should reach out to me. Otherwise, I'm going to skip some details since you guys may have done this already a lot in the previous Java courses, right? So the next reference over here is going to be pointing to null, right? Let me also put some special color over here just to remind you, right? That's the first line. What about the second line? The second line over here, let's say we create another node which would be very similar, but now notice that for the next node reference over here, we say Tom. That means somehow we want to build this node at the same time also want to connect it to the earlier node that we have just created, right? Let me now paste. So this will be the second node that we are trying to create. Let me just have consistent color. How about just green over here? All right, and what will be the element? The element will just be Mark over here. So that will be pointing to the string Mark. And Tom over here is going to be, well, remember call by value, right? If you think about Tom over here is actually pointing to this the Tom, there's something I forgot to mention. From the earlier tracing over here, Tom is going to store the reference of this node. So that means Tom is also pointing to this particular node. And don't get confused. You can see I chose all lower cases over here for the name of the variable. But this one here is just a string objects, which is capitalized, right? Don't get confused. All right. Let me go back. So how do we understand this line over here, right? So you have to understand about call by value, right? So the call by value is going to look like this, right? So you want to think about this is calling the node constructor. So what I will do is I'm going to actually let me use a different color over here. Okay, so you actually want to think about conceptually this is referring to this, and we talk about call by value. Right? Call by value simply means, let me remind you, which you're also supposed to learn from 2030. So that means n over here is going to be assigned to the reference of Tom. So that means n is actually going to be assigned to Tom in order for the rest of the method body to be executed. So that means n is going to point to wherever Tom is pointing to over here. And then when we try to execute this line, when we say next should be equal to n. So the next over here will be implicitly this dot next. And what's this? This is the current object that we are talking about right now that we're creating. So it's really this particular object. And its next reference is going to point to wherever n is pointing to. And n is really pointing to this particular object that Tom is pointing to, right? So that means we're going to set the reference like this. It will be very important for you to make sure you understand every detail over here, right? It's a very basic workout. It's a basic kind of little pieces to really make the chain of nodes actually connected, right? If you have no problem over here, and make sure you also understand how the call by value is working over here. It's also very important, which will involve n is assigned to Tom. All right. Let's now do the final line. The final line, let me use pink over here. The final line is going to follow very similar pattern over here. Let me just put the final nodes over here. Okay. Let me just give it a little bit more space. And that one should be pink, just to be consistent. Oh, sorry. The color should be pink over here. And it's going to do something very similar. So now this elements over here is going to be Allen. Allen over here. And also what will be the next node? Is going to be Mark, right? And call by value is going to be executed one more time. Meaning that we're going to say n is assigned to wherever Mark is pointing to. And where is Mark? Mark is actually from the earlier objects over here. This Mark. And I forgot to put it. Actually, Mark should be pointing to this particular object. That's the green object we just created, right? All right. So now what we can do is we can say the next is going to point to wherever Mark is pointing to, which is wherever n is pointing to, right? So now the n over here, if we do call by value again, n is actually changed. N is actually going to point to wherever Mark is pointing to for that particular call over here, right? And then we're going to say next is actually going to point to wherever Mark is pointing to according to this. And don't forget this node over here is going to be Allen. Like that. All right, you can see this approach number one. We are basically trying to do backwards over here to set up the nodes. We start from the last node, whose next reference would simply just be null, and then we go from last into second last into the first node over here, and then we simply pass the corresponding next node reference over here. If you have a very good idea about how the order should be like, you may just go for approach number one. Otherwise, if you want to give yourself a little bit more flexibility about creating all the nodes first and then do the connection, in that you can follow approach number two. That's also what you can do. All right, so before that, I would like to do one more mention about reference aliasing because I think it's so important to understand. How many instances do we have for reference aliasing? Remember, reference aliasing simply means an object is being pointed to by more than one, larger than one arrows. Like its address is being stored in more than one variables, at least two. How many? Well, you can pause the video and tell me the answer. All right, the answer should be 2, I believe, right? Let me just point out to you. So the number one is, you can see over here, Allen.next is pointing to this object over here. And Mark is also pointing to the same object. That's instance number one. Instance number two, you can see Mark.next is pointing to this node over here. And Tom is also pointing to there, right? That's at least what you can see. But to be more, okay? It's actually more slightly more complicated than you might think. That's why I want to mention that. Let me just mention one of them. You can definitely do others as exercise. Again, reference aliasing. And what I want to do as an example is, what about we talk about this particular node, the last node? How many paths do we have to really get there, right? How many? Well, I can see more than one. I can see more than two. Number one, you can definitely say Tom. That's the easiest way, right? Or it is the next node of the second node. It is, so this will be the next node of the second node, which will be mark.next. Right, and number three, right? So mark itself will also be the next nodes of the first node, which is Alan, right? So you can also say Alan dot next. That's also possible. So if you put in Eclipse, for example, to check Tom equals mark the next, it will be true. And also mark.next equals Alan.next, it will also be true, right? So Tom and also mark.next, they're pointing to the same objects. And another example, Tom and also Alan.next also point to the same objects. So these three are mutually equal to in terms of their references, right? It's very important for you to also review this point, right? All right, that's about reference aliasing over here. Let's now go on to approach number two. Okay, so approach number two will be very similar to approach number one. But the fundamental difference is we are not going to set any next node reference when we first construct the node. You can see null over here, null over here, and null over here. And what we're going to rely on will be the setNext method. All right, so let's now, again, we're only considering the node class, right? The node class over here. And the two attributes, definitely we have to make sure we know them in order to visualize. And also the constructor is also important. Let me use a different color over here. Let me use pink. All right, the node over here. And also we're gonna make use of the setNext over here. Okay. Oh, one thing to mention. So here I'm only doing some conceptual sketch. So that's why I'm saying mark.next. But of course, if you write it in Java, you must say mark.getNext. And also Alan.getNext.getNext. Just something to note syntactically. All right, so how do we visualize this, right? So we're creating Alan, Mark, and Tom separately, right? Let's now do that quickly. So let's now, hopefully it's still on my clipboard. All right, so I got one node over here, and I got another node over here. And I'm going to go a little bit faster since you pretty much know how the constructor should work. So we got three nodes here. So that'll be the intention, right? Let's now create one by one. So we're going to create in this order, Alan, Mark, and Tom. All right, let's now, so we're going to do Alan over here. And also we're going to do Mark in the middle. And also Tom, which would be blue. All right, so that'll be the idea. I try to have the same color as before, so if you want to compare the two examples, you wouldn't get confused. All right, so the first one will be, let's go from Alan, right? Alan will be basically, potentially, intentionally the first node. So I'm going to put pink. And this one here, there's no call by value for this case. It's simply pointing to null, right? It's the name will just be Alan. All right, so the element is pointing to the Alan string, and the next will be pointing to null. And don't forget, the reference or the address of the node is going to be stored by Alan into Alan variable. So it's like that, right? You should really understand why we got 1, 2, 3 pointers set up in this way. All right, the next one. The next one will be the middle node, which will be Mark, and that should be green. Let me now color that to be green. And then let's now go on to talk about it, right? It's also similarly, element will be another string, Mark. Next node will be null, and the node reference will be stored in Mark, right? Let's go one by one. So the element is going to be pointing to some string objects, Mark, data objects. And the next is going to be null, and Mark the reference variable of type node is going to point to this node objects, right? Hopefully, so far so good. The final one, right? You can see so far the nodes we have built, they have no connection whatsoever, not yet. That's why it's approach number 2. Right, so we're gonna have another variable node, Tom, and also null, right? Similarly. So now the element is going to be pointing to Tom over here, and then the next reference will just be null over here, and then Tom will store the reference of this particular node. Alright. Now you can see Alan.next is actually null. Mark.next is also null. Tom.next is also null. So there's no way to tell which one might be the end of the chain, the end of the chain. They haven't got any connection so far, right? So that's why the next 2 lines are so important over here, right? These 2 lines. Okay, so these 2 lines, let's see how we can do that. Alan.setNext will be Mark, right? So Alan over here is a so-called context objects. And we're calling the setNext method over here, right? And the next over here will be as if we set this.next, where this will just be replaced by Alan, the context objects, right? So that means we're saying that Alan.next is going to be assigned to n. And what's n? Remember call by value, right? So now if you try to do some annotation over here, that'll be call by value. And let me just highlight it. It's so important to actually see how the call by value will work over here. So call by value is going to make sure the parameter n is actually assigned to the argument mark over here, right? So you can think about n at the moment is actually pointing to wherever mark is pointing to, and then we say that Alan.next is going to point to wherever n is pointing to, right? So what's really happening here is we are trying to copy the address of n into Alan.next. It would be as if to say Alan.next, rather than pointing to over here, is going to point to wherever n is pointing to, which would be this object over here, right? It's something I hope you're feeling comfortable, right? So what we'll do is we're going to say, rather than pointing to over here, it's now going to point to wherever mark is pointing to, like this. So we set up the 2 nodes to be connected, right? And we follow a similar way, similar pattern over here. And now the context object will become mark, right? Over here. The context object is simply just mark. So that means we're going to talk about mark.next being assigned to n. And since we talk about call by value, so now call by value is going to be n is assigned to Tom, meaning that the parameter, rather than being here, parameter locally is going to be pointing to here. So what we'll do is we're going to say mark.next is assigned to n. So mark.next, rather than pointing to here, is going to point to wherever Tom is pointing to, or n is pointing to. And actually I put the wrong place over here. Beg your pardon. So n over here, as I said, I definitely said it right. N is assigned to Tom, right? So that means n should be pointing to over here. Let me do it again. So we're going to say Alan.next is going to point to wherever n is pointing to. So mark.next, rather than pointing to null, is going to point to wherever n is pointing to, which will be this node over here, right? So it's going to be like this. Right? After this, we're done. So that's effectively building the same chain of nodes as approach number 1. You can definitely compare and contrast. Let me just give you some quick visual summary. So what we have done now is we basically got one node over here, which whose next reference is pointing to this particular node over here, whose next reference is actually pointing to this node over here, whose next reference is going to remain null at the moment because it's the last node in the chain. All right, so that's about very basic operation. You should really know how to build a chain of connected nodes. You can either go for approach number 1, meaning that you're gonna build a connection as you actually construct the nodes. It's definitely more, I wouldn't say it's more efficient, to be honest with you, because the number of extra lines that you have to write for approach number 2 is actually going to be pretty much constant. You don't really have to, well, you don't really have to worry about, either having the extra lines over here. You don't need to, right? It's going to be similar, okay, in terms of the running time. But which way you may want to go is completely up to you. If you prefer having just fewer lines of code to write, by all means, choose approach number 1. But to me, approach number 2 seems to be giving you more flexibility, because you can build all the nodes you might need in phase number 1. And then in phase number 2, you can choose how you may actually want to build a connection between them. But later on, if you change your mind, for example, you may just want to let, maybe rather than Alan, Mark, and Tom, you want to make maybe Mark, Tom, and Alan. In that case, changing this way over here, just changing how you set the next reference, as opposed to actually changing the argument over here. I think this way will be much more flexible for you to change, right? Hopefully you can see my remark over here. All right. So now we learned about how you can build a chain of nodes. Let's see how you can build a list whose head will just be a chain of nodes.